don't really care about their health, and they report they eat meat, and they're actually sicker, but it may not be because they're eating meat, it's because they have other bad habits, right? And we'll talk about that. Also, white hat bias is basically when it's something that's hard to control for, but it's something where the author has a particular point of view, right? If you're a low-fat vegan advocate, you're going to do a study on low-fat vegan diets, it's likely you're going to kind of have a certain way of looking at the data and interpreting it and doing the study. Funding bias is huge, which means that a lot of the industry has funded food research that's led to conclusions that favor their product. It's not necessarily independent research. Publication bias, when something doesn't come out in the way that the scientist wants or the industry wants, it's not published. So we only see studies that show a positive outcome. And also, it's very expensive. There's very little money that's spent on nutrition science in this country, and a lot more that's spent by the food industry. And of course, limited data sharing is an interesting thing we don't really talk about much. But for example, the NIH funds large trials, public health trials like the Nurses' Health Study, Physicians' Health Study. This is Harvard data. You think that data would be accessible to all scientists to look at and analyze, but in fact it's not. It's held by the original researchers who got the funding as their proprietary data, which limits the ability for other people to look at it, understand it, dissect it, and analyze it. All right, so this is interesting. This is talking about the reliance on these food frequency questionnaires as being problematic. This is from Mayo Clinic Proceedings a few years ago. The reliance on these food frequency questionnaires to inform dietary policy continues. It's actually what we use to determine our dietary guidelines, despite decades of unequivocal evidence that these questionnaires bear little relation to the actual energy and nutrient consumption. So look, we're going to show you how that explains. You probably all heard of this study, came out last year in Lancet, Dietary Carbohydrate Intake and Mortality, a Prospective Cohort Study and Meta-Analysis. And you can see by this graph, the people who ate the very low-carb diets didn't do good. The ones who ate the high-carb diets, not so good either. The ones who ate sort of moderate 50% carbs, 40-50% carbs, seemed to live the longest. And the headlines confirm this. Low and high-carb diets increase risk of early death, study finds. Now, that kind of headline confuses the heck out of people, because it seems like this is coming from the Lancet, this is coming from Harvard researchers, this is a credible study, and we should believe it, and eating low-carb will kill you. Right? You all probably heard this, and I'm sure you were all confused by it, so was I. So I started looking into what the study actually showed. Newsweek was a little bit less forceful. They said low-carb diets may cut years off life. Study suggests. That's a better title. But this is the issue here. So we take these conclusions from these studies, and we use observational studies to draw conclusions about causality. That is a big mistake. The purpose of these epi-studies is to generate hypotheses so that we can then look at those in clinical trials. But that's not how they're used. They're used to inform dietary policy and guidelines. We rely on these false and inaccurate food frequency questionnaires. We don't adjust for confounders. We focus on quantity, not quality. Was the carbohydrate from, bread or sugar, or was it from broccoli, right? Was the fat from trans fat, or was it from omega-3 fat? That matters, because as Jeff has taught us all, food is information. Food is information. It's a biological response modifier. It's not just energy, right? And then they group data from lots of different sources and come up with these conclusions, and then become, the headline. So this is more talking about the fatal flaws of food frequency questionnaires and how there's underreporting of energy intake in women, particularly the magnitude determinants in effect training. So this is a huge issue. So why are food frequency questionnaires problematic? And the reason I'm spending a little bit of time on this is where most of our nutrition data comes from, right? People underreport foods that are considered bad, right, like red meat, and they overreport foods that are considered good, like vegetables and fruit. They obviously are eating all the time, and they may not be eating at home and knowing what they're putting in their food, so they don't report accurately what they find in restaurants. They don't weigh or measure their portions. They don't track every bite and meal because it's inconvenient. And they're human. They just can't remember everything, even if they're well-intentioned. And people's diets change over a long period of time. So let's look at this low carb will kill you study. Well, first of all, there were 2 food frequency questionnaires over 25 years, separated by about 6 years. That's their data. The average calorie intake reported was 1,500 calories. Now, the average man eats about 2,500 and woman eats about 2,000. What happened to the missing 700 calories? Was it a sheet cake? What was it? How can you even draw a conclusion from a study that misses a third of the calories that you don't even know what they are? And the low-carb diet wasn't low carb. It was 40% carbs, right? Low carb is less than 10%, right? Or 5%, some people say. And the other thing is these low-carb folks somehow were in the group that smoked more and exercised less and were overweight. So no surprise they didn't do so great. And they didn't assess diet quality, just protein, fat, and carbs. So you can see why we draw these conclusions from the headlines, but the data doesn't just support that. And it has a lot of other flaws and questions. So let's look at epidemiology. There's a guy named John Ioannidis who's pretty vocal about this. And there are, I've interviewed, epidemiologists, I've interviewed clinical trialists, and there's this incredible war going on in science where the clinical trialists will go, well, epi studies are great for generating hypotheses, but you can't rely on them for anything, and they're not that helpful. Whereas people who are epidemiologists say they're super helpful. Well, the truth is that they can be helpful, but not in the way we currently interpret them. For example, the smoking link and cancer was through epidemiology, but the increased risk was 20 to 30-fold higher risk. That's like 2,000 to 3,000% increased risk, right? When you look at, for example, processed meat and colon cancer, the risk is 18%, which is 0.18 increased risk, not 20 to 30 increased risk. So what does that mean? Well, it's probably just noise. There may be some signal there, but it's probably just noise because you can't draw conclusions from epi studies unless the hazard ratio is at least over 2 or more. And again, in smoking, it was 20 to 30, not just 2. So that's part of the problem. So Dr. Ioannidis looked at some of this. His 5 out of the 6 most cited claims of observational studies were refuted within a decade, meaning we draw a firm conclusion, we change medical practice or eating behavior, and then a few years later they go, oh, we got it wrong. Another review looked at why most published research findings are false. Only 20% of observational studies were validated in follow-up randomized trials. That means 80% of the studies that we rely on to determine our nutrition guidelines are overturned or not accurate. Another review, 52 of 52 major epi studies were not validated in randomized controlled trials. Now, Bruce Ames, who won the Linus Pauling Award at the Institute for Functional Medicine, has been a mentor and teacher for many of us, father of the Ames test. He gave a talk once at IFM, and he said, I have a problem with epidemiologists because if you send a bunch of epidemiologists to Miami, they're going to find that everybody is born Hispanic and dies Jewish. So what do you make of that? I could do an epi study on women who are over 55 who have sex, and I would conclude that sex never leads to pregnancy. Accurate, but it's not valid, right? It's not valid. Accurate, but not valid. I once asked Thomas Insel, who was the head of the National Institutes of Mental Health, I said, what do you think of the DSM-4? Was it 4 at the time? He said, well, I think it's 100% accurate, but 0% valid. Meaning it's great at describing symptoms, but doesn't tell you anything about the disease. So let's look at an example of this. The randomized trial. Wait, do I have 40 minutes? No, I'm so confused. I thought I had an hour and a half. Because the clock is, I'm in a time warp here. Okay. I was talking slower than usual, but I didn't think it was that slow. I had a disease I inherited from Jeff Bland. It's called cerebral fibrillation with rapid mandibular response. And I've spent years in therapy trying to fix it. But anyway, I didn't think I was talking that slow. So you all heard of the Nurses' Health Study, big Harvard study. Was very clear that women should take hormones. In fact, a woman at Canyon Ranch, when I was working there, came to me, this was in the 90s, said, because I was questioning, because the data was starting to come out that there were issues. I was questioning the validity of giving every woman postmenopausally Premarin and hormones. She said, my doctor said, if you don't give me hormones, it's malpractice. I'm like, oh, okay. And then this was in 1991, 44% risk reduction in heart disease for women taking estrogen and a reduction in mortality. Sounds like a good deal, right?